Sampling designs and research methodology. Sampling design is a crucial aspect of research methodology, as it determines how researchers select individuals or groups from a larger population to represent the whole. This is essential in obtaining reliable and valid results without needing to survey an entire population, which may be impractical or impossible. Effective sampling allows researchers to make generalizations about the broader population, making their findings more impactful and applicable. There are two main types of sampling designs: probability sampling and non-probability sampling, each with its own set of techniques. Probability sampling. Probability sampling involves selecting a sample in a way that every member of the population has an equal chance of being chosen. This type of sampling is particularly useful for ensuring unbiased and representative results. Common techniques in probability sampling include simple random sampling. In this method, each member of the population has an equal chance of being selected. Randomization is key here, and researchers often use random number generators or draw lots to achieve this. This method is ideal for eliminating selection bias and ensuring the sample is representative, especially in a homogeneous population. Systematic sampling. This method involves selecting members of the population at regular intervals, e.g., every 10th person on a list. Researchers first decide on a starting point and then choose participants based on a consistent interval. Systematic sampling is straightforward to implement and can be effective when the population list is ordered randomly. Stratified sampling. Researchers divide the population into subgroups, or strata, based on shared characteristics, e.g., age, gender, or occupation. They then randomly select individuals from each subgroup to ensure representation from all important segments of the population. This method is particularly beneficial when researchers want to understand differences between groups within the population. Cluster sampling. In this technique, the population is divided into clusters, often based on geographic regions or other natural groupings. Researchers then randomly select entire clusters and include all members within the selected clusters in their study. This method is useful when the population is widely spread out or when individual sampling is too costly or time-consuming. Non-probability sampling. Non-probability sampling is a method where not all members of the population have a chance of being selected. While this approach may introduce some bias, it can be useful in exploratory research, where the goal is not necessarily to generalize findings to the broader population. Techniques in non-probability sampling include convenience sampling. Researchers select participants who are most easily accessible. For instance, they might survey people who are available at a specific location. Although this method is less rigorous, it is often used in preliminary studies due to its simplicity and speed. Purposive, judgmental sampling. In this technique, researchers select participants based on specific criteria related to the study's goals. For example, they might choose individuals with expertise in a particular area. This method is useful when seeking in-depth insights from a targeted group but may introduce some selection bias. Snowball sampling. Commonly used in research involving hard-to-reach populations, this technique relies on initial participants referring other participants who meet the study's criteria. Snowball sampling is helpful in qualitative research, such as studying marginalized groups or niche communities. Quota sampling. Researchers divide the population into categories, e.g., gender or age groups, and set quotas for each category. They then select participants who fit these categories until the quotas are filled. While similar to stratified sampling, quota sampling does not use random selection within the subgroups, making it less representative but still useful for ensuring diversity in a sample. Importance of sampling design. The choice of sampling design directly impacts the quality and generalizability of research findings. Probability sampling methods provide stronger evidence for generalizing results, making them ideal for studies where representativeness is essential. Non-probability sampling, on the other hand, is valuable in exploratory research, allowing researchers to gain insights in a cost-effective and timely manner. Ultimately, selecting the appropriate sampling design depends on the research objectives, available resources, and the characteristics of the population under study. A well-chosen sampling design enhances the accuracy, validity, and reliability of the research, contributing to the overall success of the study.